Welcome. In this lecture, it is the detailed one shot of work, energy, and power. So, yeah, let's get into the chapter. First, we need to see the formula of work definitely, which is dW is equal to F dot ds, where F is the force in which what you wanted to find work. For example, if you want to find the frictional force, work done by the frictional force, this F will represent the friction force. If you want to find the work done by spring force, let's say, this will represent the spring force. So it is basically the force which you wanted to find the work of, right? And the ds is the displacement of the point of application of the force. So the displacement is basically called as ds, and dw is the work done. That's what we are seeing the formula for. So yeah, when an object is moved a distance s, the work will be done when a force is applied to it. Okay, dw is equal to F dot ds, and w net will be this is a small work done, right? So if you wanted to find the total work done, you definitely need to integrate it for sure. So when you integrate it, you'll get integration of dw will be equal to integration of F dot ds, as simple as it is. Okay, this formula can be used in some questions. And if f is constant, f comes outside and it will be forming like this. And integration of ds is nothing but the displacement itself, and the final formula, when f is constant, we are gonna use F dot s. Okay, so which does actually mean, this actually mean the area under the F versus S graph will represent the work done by the force F. Okay, so yeah, so as I said, F dot S, work done will be F dot S. So F dot S will basically mean Fs cos theta. Okay, so either you can take the force as the component in the direction of the displacement, or the displacement as the component of the direction of force. So either of the two ways you can take that. So in this case, I've taken like F cos theta d, the force component in the direction of displacement. Fine. This is another case where displacement component is taken along the direction of force. So when force is constant, we have seen the formula this. So by applying the formula, we get, when the we observe that theta, when theta is equal to 90, work done will be basically equal to 90. When theta is lesser than 90, work done will be greater than 90, and when theta is greater than 90, work done will be lesser than 0. Fine, sorry, before I said 90, it's 0, right? Work done will be greater than 0. Okay, so let's see a question on that. Let's take a 10 kg block, and we are moving with the force F naught is equal to 100 newton to 10 meters. So which will be in a surface where the mu is given as, the constant of friction is given as 0.4. So basically we need to find the work done by the F naught and work done by the friction. So work done by the F naught, we need to just take this value. So 100 newton is done by the F naught multiplied by the distance traveled, which is 100 meters, multiplied by 100 multiplied by the angle between the force and the displacement, which is of course 0 in this case, because force is in this direction and displacement is in this direction. So the answer will be 1000 joules. And if you talk about friction will be opposite to the movement of the object, the relative movement of the object. So basically, since the object is moving in this direction, the friction will be acting on this direction, and simply the friction is can be calculated as frictional force can be calculated as mu multiplied by the n. So mu is 0.4 in this case, and n is nothing but here in this case we are going to consider the mg, because mg is equal to n. So it's going to be multiplied by 100, which is 40 Newton. So that we have got the n value. So n value multiplied by 10 multiplied by cos 180, which will give you the total work done by the friction. Fine. And what about work done by the gravity and work done by the normal force? Gravity is 90 degree. So as we see, when angle is 90 degree between them, work done will be 0, and the same goes to normal force. Fine. So work done by the all forces is nothing but the work done net. So simply it's going to be the sum of every forces. You can either do it in this way, or we will be learning another way also. You can also either do it in that way if you have all the informations related to it, and you can also do it like take f net and multiply it by the distance. So basically here you can see 100 Newton is going here, frictional force is acting, which is 40 Newton. So f net is on this side, which is 60 Newton. So 60 Newton will be multiplied with 100 and the 10. So this will be equal to 600 joules of work is done. The next is work energy theorem. Work done by all the forces is equal to the change in kinetic energy. So work done by all the forces, which means gravitational force, normal force, let it be spring force if spring is there. So all the forces sum will be basically equal to the change in kinetic energy. For example, in the previous question we have seen they have additionally asked a question. Let's say find the final velocity. So basically we have seen the work done by all the forces is basically equal to 600. So 600 will be equal to the change in kinetic energy for sure. So initial kinetic energy is basically 0, because I think it starts from rest, right? Yeah, it starts from rest, so initial kinetic energy is 0. So 1 by 2 mv square. So in this case vf square for final kinetic energy, and of course you can find the final velocity. It's not a big deal. You can also solve this in a traditional method, which is basically Newton's laws of motion method. So which is basically here 100 Newton is acting, in this side 40 Newton is acting. As I said, F is going to be equal to 60 and F is equal to ma, and mass is given as 10 a, and which is equal to 60, which is basically equal to meter per second square will be the acceleration. So since we have found out acceleration and it is constant in this case, so we can apply in v square is equal to u square plus 2as. So u square is given as 0 and a is found, and s is 10 because it moves 10 meters, and v square we need to find. So basically it's simple old technique which you guys have must known if you have studied in the work done by variable forces. So basically work done by the variable forces, you need to do it by the formula work done is equal to integration of f dot ds. So if for example if force is like this, and if you want to find the work done when it travels from x equal to 0 to x equal to 3, so work done by the force is equal to integration f dot dx. You just need to integrate it and you will get the answer. Okay, if dx, dy, dz, all the three directions, if a vector quantity is there, you need to simply do it separately with the different force components. So work done will be equal to integration of fx dx plus integration of fy dy plus fz dz. So if you do this, you can basically get the work done. So let's see a question to clarify this. So let's say we need the force is this and we need to find this. So force is equal to 3x square. This is dx component, right? So the 3x square dx, okay, and it goes from 1 to 4. So 1 to 4 and 2 to 6, 2 to 6, 2y, which is this dy, and hope you understand this also. And if you integrate this, and the answer will be right in front of you. So f is equal to 3xy I cap plus 2y square j cap. If particle is displaced from 1 comma 2 to 3 comma 4, find the work done final. So this is a pretty different question because we have two different variables in the single direction itself. So in that case we need additional information, something like this. So in this case just substitute the value of y in the place of y and simply integrate dx, integrate 12x square dx, and you will probably get the answer. Fine. So next question is f is equal to minus 10x, okay, x I cap. So we need to find the work done from x equal to 2 to x equal to 4. Work done is equal to integration of f dot dx. So as you all know, it's just a simple problem. You just take minus 10 outside because it's constant, and we need to integrate x from 2 to 4, 2 to 4, and you can get the answer. So this is a case of let's say it's in the case of spring force, because the next topic is spring force. The spring force, let's say the spring is there and it is of natural length. If it is extended, we know that spring force will be basically equal to minus spring constant multiplied by the what is that, extension, right? So yeah, so force and displacement is in opposite direction. So basically whenever the spring is pulled, the displacement will be in this direction and the force will be in this direction. Do you agree with this? Okay. Whenever it is compressed, like it's compressed like this, we know that the force will be in this direction, displacement will be in this direction. So yeah, in spring case it will definitely be in opposite direction, if not any hypothetical things come in ideal case it will be in opposite direction. Work done by spring force. So basically let's take a case, and let's say here it's the natural length and the initial extension is gonna be x initial, okay, and f naught constant is applied. So this is not required if the question is asked work done by the spring force, because we need to take only the force which spring makes, right? So another force is this, and the distance between this natural length and the final position is x final. So in that case we will simply integrate f sp dx, right? So from x initial to x final minus kx dx, if we integrate it we'll get something like this. This is the important result which you can directly remember, which is work done by spring force is equal to minus 1 by 2 k x final whole square minus x initial square, where x initial is the initial elongation or compression and x final is final elongation or compression. Okay. So remember this formula, this is very important. Next thing is So basically in this question we have a question like we need to find the work done by all the forces separately and together, work done. So basically there is a block and connected to spring which is having a spring constant 100 Newton per meter, and this is at rest. So F naught is equal to 1000 Newton. So basically a force is acting like this. After a certain time, it's gonna be 2 meters ahead of the natural length, and we need to find the work done by all the forces. So let's take the first case, work done by the F naught. Take only the F naught numerical value and multiply it with the distance which is traveled, which is 2 meter in this case. So we will get 200 joules. Okay, work done by the normal force. So normal force is basically 90 degree. So whenever the force is of 90 degree, the work done will be basically equal to 0. So similar to that, gravitational force will also become 0. So what is work done by the spring force? It is basically equal to minus 1 by 2 k. It's k guys. So it's k. Okay, x final. So here x final is, let's take it as 2, and initial is at natural length, right? It's not let's take it as, I've mentioned a wrong sentence. If it is of natural length and the object is in the natural length itself, then the elongation, there is no elongation, there is no compression. So x initial is 0 and x final is 2 meters from the natural length, which we will take 2 itself. Okay, and then apply the formula and we will get minus 200. Okay, and then this work done by all the forces will be basically the sum of all the forces, which you can add this and this and this. Fine. So yeah, we can also find it by the change in kinetic energy. Work done by all the forces is equal to change in kinetic energy, which is work energy theorem. So 1 by 2 mvf square. If we know the kinetic energy, sorry, we know the work done by all the forces is 1800 joules. So we can also find the final velocity. Fine. We have another question. Find maximum elongation of the spring and find is that in equilibrium. Okay, so same question, I think. Work done by all the forces will be equal to change in kinetic energy. So basically work done by gravity plus work done by normal force, work done by spring force plus work done by F naught. So yeah, I think this is the same question, but we need to find the maximum elongation. So let's take this as maximum elongation. Okay, so when maximum elongation, so what do you mean by maximum elongation? So basically if this block is this block, let's take this as a block, and it can't move further, right? So that is basically maximum elongation. So it can move in this direction, but it shouldn't move in this direction. At that instant, v final velocity will be equal to 0. In this case it's gonna be v final. Okay, velocity will be equal to 0. Fine. So yeah, apply the velocity is gonna be equal to 0. So initial also it starts from rest and final also it's become 0. So initial kinetic energy is equal to final kinetic energy, which is equal to 0. Fine. So 1 by 2 k, so x max square minus 0 square. So if you apply this formula and also add this value multiplied by x max, you will basically get the value of x max. Okay, and what about whether it is in stable equilibrium, whether it is in equilibrium or not? So to find that, so you need to know NLM, which is basically F net. So here F naught force is acting, which is 1000 Newton, right? And here kx max will be acting, right? So what is x we have found? We have found that as x max is 20, right? 20 multiplied by k is 100. So we'll get 1000, which means it's gonna be something like this, and the f net value will be in minus 100, oh sorry, 1000. So which means f naught is not equal to 0. When f naught is not equal to 0, it is not in equilibrium. Okay, the next question, find the maximum elongation in the spring. So basically we have a block connected to a spring and it is gonna drop when it is in the natural length. So when it drops, I can tell that it goes to x max. Again, the x max is not the position where it is gonna be in equilibrium. Okay, it goes like this and comes back to the equilibrium position. Okay, so which is at really equilibrium is it's definitely its natural length, right? So yeah, so work done by gravity plus work done by spring force will be definitely equal to change in kinetic energy. Of course you can put x max in this case because x max vf will be equal to 0, so 0 minus 0, and apply the formula of work done by the spring and you can get the x max value. Next thing is inclined plane based questions. So basically there is an inclined plane and the mass m is placed on the top of the inclined plane and it is let to drop. So it is dropping, and you can see a distance L has been dropped, and this distance, this height is given, which is h, and this angle is given, which is theta. So we have asked to find the final velocity. So basically let's take in the middle of this, how will the free body diagram will look. So basically a normal force will be acting and mg force will be acting, and the friction force will be acting if the friction is mu, right? Let's take friction as mu, it's not mentioned in the question. Let's take this is mu friction. Fine, now coming back, so since it's mu friction, the friction force will be acting on the opposite direction of the motion. So mg sin theta, mg cos theta are the two components. So work done by gravity plus work done by normal plus work done by the friction will be equal to change in kinetic energy. And remember that work done by gravity will be taking the distance only on how much height it is. So basically either it travels like this, either a body travels like this, or either it travels like this or travels like this, any direction it will be taking the distance of how much height is it from the ground. Okay, that will be the work done by the gravitational force, the perpendicular height. Fine, so in this case we need to take this height. Okay, and we need to take this height. So this height is h, right? So mgh will be the work done. Mg is the force and h is the displacement in the vertical direction. It is only taken vertical displacement, right? So normal will be always perpendicular, so I can take it as 0. And what is work done by the friction? So friction is basically mu n, right? So in this case minus mu mg cos theta, because why minus? Negative work is done because it is opposite to the direction of the displacement, and which will be equal to the change in kinetic energy. So you can find the value of final velocity. Also remember, whenever a situation comes like climbing up or going up, the work done by gravity will be negative. Whenever a case of climbing down or falling down or drop, that will be positive mgh. Okay, the next thing is a question. So definitely we have a lot of questions here. So how much ever questions you would do, the more the experience you get in this chapter. So yeah, I will almost cover every type of questions in this chapter which is required for JEE Mains as well as in JEE Advanced. Okay, so a mass m and the spring is there. The mass m is dropped in the spring thing, and when it drops you can visualize it, the spring will get compressed, right? So it's gonna be like this. So what will be the maximum spring compression they're asking? So at this point, can I tell it's gonna be equal to 0? Okay, and if this is x max and this height is already h and the body is here, the work done by the gravity will be simply equal to mg h plus x max, right? So this will be the distance in the vertical displacement, which is h plus x max. So minus work done by the spring. So it is at the natural length here. So when it goes down, it's gonna be compressing x max. So the compression is x max here, x max square, and you can solve the problem. At this point, v final will be equal to 0. Yeah, you can solve this. The next thing is again another question where a mass is released in a vertical plane and it's gonna be going like this, and we need to find the maximum compression again. So the value is given mu here. So yeah, work done by what are the forces are there in this block? So basically work done by gravity is there, friction is there, spring force will be there, and then yeah, normal is there. Fine, these are the forces which are acting in the block. So yeah, when this reaches here, the spring force will be acting definitely. So work done by gravity, work done by normal, work done by spring, work done by friction will be equal to the change in kinetic energy. So basically it is coming down, which means it should have positive work done by gravity, right? So mg x naught. So x naught is the distance here, initial distance, plus x max. So basically this distance after compression, this is going to be x max. So this component of this will be sine theta multiplied by x max plus x naught. So mg multiplied by this will be the work done by the gravity, and of course this is the work done by the spring, you can actually see it, and the last is which is friction, right? So friction is definitely in the opposite direction, which means it's doing a negative work. So mu mg cos theta, so n will be mg cos theta, so mu mg cos theta, right? So this is what it's written here, and the displacement, so that will be equal to 0 minus 0, which is change in kinetic energy. You can solve this and they get the value of maximum compression, which is x max. Fine. Next thing is a different question, but it's not at all tough. Let's say this point is fixed and here a particle is there and it moves here, it is dropping, and this is the initial position and this is at the natural length in this case, and this is a sphere of radius r, and what we need to find the final velocity when it reaches here. So again, work done by all the forces is equal to change in kinetic energy. In this case, normal force is there, spring force is there, and then gravity is there. mgr minus 1 by 2 k. So yr, we need to take only the vertical displacement. Okay, so vertical displacement here is basically r distance from the center, right? So this is uh, in the opposite, like parallel to the center. Of course this distance will be r, so the work done will be mgr, work done by gravity. Fine. We can also find the work done by the spring, which is 1 by 2 k x final. So x final minus x initial will be 0 because it's going to be in natural length, so it's going to be 0, and yeah, plus 0 will be equal to 1 by 2 mv square. And initially, since it is dropping, so initial velocity will be equal to 0, so initial kinetic energy will be equal to 0. Okay, you can find this. So there is another similar type of question where this point is fixed and a object is there here, and it is going to move in this direction. So when it moves, basically it attains, we need to find the final velocity when these all conditions are given: 4 meter, 5 meter, 37 degrees. Fine. So basically the natural length is 3 meter is given, so which means initially the compression is 5 minus 3, which is 2 meters, and finally the compression is 4 minus 3, which is 1 meter. So yeah, with this you can find the work done by the spring force, and work done by the normal and the work done by the gravity will be equal to 0 because it is perpendicular forces, and you can find the values. Again, a same type of question where natural length is given as 3 meters. I think this is the very same question, but in this case work done by the gravity is not perpendicular, instead it is on the direction of the motion of the displacement. So what will be the displacement? So basically here 5, here 4, so this is going to be 3 meter by the Pythagoras theorem. So yeah, you can put this value and find the work done by the spring, plus normal will be 0 in this case, and the change in kinetic energy. Right? So this is a summary of this. So work done by the final force will be, work done by the force will be equal to integration of f dot dx. Okay, and v is gonna be dx by dt. We all know, we have studied in kinematics. So when we combine both of these, okay, this dx I'm gonna take on this side, so we'll get dx is equal to v dt, right? So I'm gonna substitute in this equation, which gives me a completely new equation which is derived from the previous equation, which is work done is equal to f dot v dt. Fine. So let's take a questions to understand this even better. So when a mass is equal to 2 kg, a particle's mass is equal to 2 kg, and it performs motion with velocity is equal to 2t square. T is equal to 0 to t is equal to 2. We need to find the work done by the force. There are two methods. You can either go by the easiest method, which is easiest and clear method. You won't get a lot of confusions here. So put v is equal to 0, put t is equal to 0 and you will get v is equal to 0, right? So similarly put t is equal to 2 and you will get v is equal to 8. Of course you got initial and final velocities. You can actually find the initial kinetic energy and final kinetic energy. By subtracting them you will get the work done by all the forces, which is 64. Another thing which we have another method is based on the concept we have learned it before. So basically work done will be equal to F dot V dt, okay, where F is equal to MA V dt. Fine, M is given as 2, right? And we need to find that 0 to 3. How 0 to 2? 0 to 3. So it's simple, like we need to SVA rule, okay. Velocity, when you integrate it you will get the displacement, and then apply t is equal to 0 and t is equal to 2, and you will get 0 to, and you will get at t is equal to 0 you will get 3 meters covered, and t is equal to 2 you will get 3 meters covered. So yeah, apply this and get the answer. What I would suggest is this will be an easy method for you where no confusions will be coming. So if more information is given, you can better go to this thing, right? Next thing is power. So basically let's take an example. Let's take a boy is pushing this block, fine, and he takes t is equal to 10 seconds to push it, like 10 meters, okay. So what will be the work done by the boy? So work done by the boy will be basically equal to what? So let's say he delivers a force of 10 Newton, okay. So 10 multiplied by 10 will be the work done by the boy for sure, right? So that will be 100 joules. So what if the same boy pushes this, instead of t is equal to 10 seconds, what if the boy pushes and t is equal to 5 seconds? Of course the work done will be the same. Work done will be the same, but the power will be increased, which means the boy has actually put it more power. That's why he could push it in 5 seconds instead of 10 seconds. So yeah, power is dw by dt, rate of change of work done, okay. So which can be also written as F dot ds by dt. So ds by dt, you can say that it is the velocity. So power final formula will be basically equal to P is equal to F dot V. So you can apply this formula even for constant and variable forces. Fine. So P is equal to dw by dt, and if you take dt on that side, okay, if you take dt on that side and integrate on both sides, you can clearly say that in the graph of P versus T, the area under the graph will be the work done, which will be equal to the change in kinetic energy. So let's see some couple of questions, and the rest of the things you please do it as a homework. Right? A particle of mass m moves with a velocity a root x, where a is a constant. Find the total work done by all the forces during the displacement from x equal to 0 to x equal to d. So basically put x equal to 0 and find the value of v, and put x equal to d and find the value of v. and you will basically find the change in kinetic energy, which will be equal to the work done by all the forces. Refer the solution and try to solve it by yourself. The next question is, a particle is placed at a point A of a frictionless track ABC. Fine. It is pushed slightly towards right. Find the speed when it reaches the point B. So it is pushed slightly and the particle moves like this and it reaches B, and we need to find the speed when the particle reaches B. So basically we need to use work energy theorem. Work done by all the forces will be equal to the change in kinetic energy. What all the forces are acting is basically normal force and mg. Fine. So normal, when you take a gravitational force, it's basically the distance, the vertical displacement should be taken. In this case it's going to be 0.5 meter. So yeah, put 0.5, which is 1 by 2 mg, and this will be equal to 0. Work done by the normal will be equal to 0, and yeah, initial kinetic energy is also 0, so 1 by 2 mvf square. So you can find the final velocity. Next question, a point mass of 0.5 kg is moving along x-axis as x is equal to t square minus plus 2t, where x is in meters and t is in second. Find the work done in joules by all the forces acting on the body during the time interval. So uh, so basically work done by all the forces, you just need to differentiate it to get the velocity equation. So when you get the velocity equation, put t is equal to 0 and t is equal to 2 in the equation, and you will certainly get initial and final velocity, and you can find the change in kinetic energy, which will be equal to work done. These are easy problems, and these are certainly asked and inspired from JEE mains questions. So yeah, we will be seeing JEE mains questions also in few minutes. Just wait. A sleeve of mass 2 kg at origin can move on a wire of parabolic shape. X square is equal to 4y. Two forces F1 is equal to 6 Newton and F2 is equal to 8 Newton are applied on the sleeve. So yeah, two forces are applied. So this force will be on I cap direction, and this force will have two components like this. Fine. So yeah, I think we need to find the work done by both the forces separately and add them both at the end. Yeah. So 6 I cap, basically the force F1 is 6 I cap, F2 is basically, you need to separate them, okay, which is cos theta. This will be F cos theta, F sin theta, F sin theta, and this will be F2 cos theta, right? F2 sin theta, F2 cos theta. Of course, you can find the value separately in I cap and J cap, and then the distance, and finally the dot product of both, and you'll get 24, and you get the value for this, and then solve the answer. Next question is, a body is moved along a straight line by a machine delivering a constant power. So this is an important type of questions. Like a lot of questions are like in this manner in whenever a power question comes, and whenever they say power is constant, I think the same thing is followed. So when power is given constant, so Fv will be constant. So because power is equal to Fv, okay, so Fv is constant, so MAV, right? F is equal to MA, so MAV is also constant. So taking M on the other side, so because M is constant, so constant multiplied by the constant divided by the constant will make another constant. So v dv by dt is equal to some constant, a new constant. Okay, from where dv by dt came, it's basically a converted into dv by dt. So take dt on the other side and integrate both sides, and you will get v square by 2 is equal to kt. Okay, we need to find the distance moved by the particle in time t is proportional to, right? So v is basically proportional to root t, and differentiate it once again. Sorry, we know that dx by v is equal to dx by dt, right? So dx by dt is basically equal to k t 1 by 2, and integrated both sides by taking dt on that side, and then you will get x is equal to 3 by 2 t to the power 3 by 2, and that will be the answer for this question. So yeah, same type of question. At time t, a particle starts moving along the x-axis. If its kinetic energy increases uniformly with time t, the force acting on it must be. So what they have given is kinetic energy increases uniformly, which means the differentiation of kinetic energy will be constant. So dk by dt is constant. The only tough thing is in this type of questions is basically the thinking of this, getting the key idea of the question. So if you find dk is equal to dt, dk by dt is equal to constant, it is actually easy after that. So kinetic energy I can write 1 by 2 mv square. So differentiation of this with respect to dt will be constant. So 1 by 2 m2v dv by dt is equal to constant. I have taken 1v outside and I have taken like dv by dt. So I take everything on the other side, and that will become a new constant and integrate it. Of course, you can find whatever they ask for. What are they asking? Find the net force acting. What are they asking? If the kinetic energy increases uniformly with time t, the net force acting. Okay, they're asking the net force, which means you need to find the acceleration of that, right? So the next is another question. Like, we have a lot of questions. Just try to solve it by yourself, or let me explain. So basically force equation is given in terms of x, so basically integrate it by the limit 0 to L, and you'll find the work done. This is not a tough question. A time dependent force F is equal to 60 acts on a particle of mass 1 kg. So MA is equal to 60 and M is given as 1, right? So A will be equal to 60. If the particle of mass starts from rest, the work done by the force during the first second will be. So yeah, we have got A is equal to 60. So integrate it and get 60 square by 2, which is basically 3t square, and we need to find the first second, right? So t is equal to 1. So basically 3 square 1 by 2, and the final will initial will be equal to 0, so you can find the work done. As simple as that. Do this as your homework, and yeah, again do this also as your homework. This is easy. Here is the solution for that. Okay, try this and check with the solution. Yeah, a particle experiencing a force given by what's there in this. Force is given, displacement is given, so dot product will give you the work done. The particle had kinetic energy 3 joules at the beginning. So kinetic energy initial is given, then find the kinetic energy at the end of the displacement. So basically we need to find the kinetic energy final, which is easy. A particle moves from, we have given a graph which is force versus distance, and we can clearly say that the area under curve will represent the work done. Okay, what are they asking? The kinetic energy of the particle after it travels 3 meters. So 3 meters, so basically its area will be the answer, right? Next question, a particle is released from point A. Find the kinetic energy at point B. So yeah, work done by gravity is there. So we need to find this distance between them, which is basically 1 meter, right? So this is 2 meter and this is 1 meter, and the displacement is basically 1 meter along the y-axis. So this 1 meter will be used in mgh, which is h is equal to 1 in this case. So plus 0, which is normal force is perpendicular, so it will be 0. And yeah, kinetic energy equation, and you can find the answer. Next, again this is a easy question, you can find the answer. So the equation is given, and then yeah, integrate it to find the work done. So basically we will get 0, but option is not given, but just cross check once, do it as a homework. Yeah, what about this? So the question is, a small block starts slipping down the, so basically there is a block here, and this is starts slipping, and here the coefficient of friction is 0, and here the coefficient of friction is mu, which is k tan theta. Fine. So basically apply the work energy theorem to find the value of k. Okay, so initially it's at rest, and finally they say it will come at rest, and they have also given an additional information, which is bc is equal to 2ac. Okay, 2 times ac. So yeah, work done by the gravity will be equal to simply here to here, right? So it is, if we take this as x, they have said this will be 2x, so this length will be 3x sine theta. Okay, so mg 3x sine theta will be the work done by the gravity. Work done by the normal will be equal to 0, and work done by the friction will be equal to mu mg cos theta. Sorry, here I think I left something, multiplied by the distance of this. So it's gonna cover this distance, which is 2x, right? So multiplied by 2x, which is equal to 0. Yeah, you can find the answer by shifting the variables. I think you will get the answer. So again, the question based on the constant power. So a body starts from rest and moves in a straight line. After 9 seconds, the body has moved a distance in meters. So basically, they have given the mass is equal to 2 kg, and it is derived in constant power, which is 1. So F is equal to 1, MAV is equal to 1, and mass is given as 2. So 2AV is equal to 1. Okay, what are they asking? After 9 seconds, the body has moved a distance. So first we need to take dv by dt and take 2 on other side, and then differentiate, reintegrate. After next step, you will get this relation and convert it into like this, and yeah, again integrate, you will get s displacement, and you will get this 18. Fine. So next question, a body of mass 1 kg dropped from a height h reaches the ground with the speed. So Vf is given, the value of work done by the air friction. So Vf is given as 0.8 root gh. Again, mass is also given, which is 1 kg. So when it is dropped, definitely the initial kinetic energy will be zero because the velocity is zero. So there will be two forces acting, which is air friction, due to air friction, and due to gravity. So definitely due to gravity, since it is h distance away from the surface, you will just mgh plus work done by the friction will be the rest of the force, which will be equal to the change in kinetic energy, because no other force are acting other than these two forces. So this minus this will be basically equal to work done by the air friction. So yeah, this is an important formula, just try to remember this. Two solids A and B of mass 1 kg and 2 kg respectively are moving with an equal linear momentum. The ratio of the kinetic energy will be A by 1. What will be the value of A? So basically this is the relation between kinetic energy and the momentum. So just put the values here and find the ratio of kinetic energy. I think this is pretty simple. So yeah, this is the same type of question. Take a screenshot and please do it. Okay. Yeah. Last two questions, and then we'll go for a new concept. An automobile of mass m accelerates, starts from origin and initially at rest, while the engine supplies a constant power P. Again, the constant power, I think you know how to do this. Okay, we need to find the position as a function of time. The same method, but the different question. The physics is same, but the mathematics is slightly different. So yeah, a block of mass m is moving with the kinetic energy E. So this is the kinetic energy, and compressing the spring. So which it is compressing the spring as the speed has been halved, which means the final velocity will be equal to 0, and the compression of the spring will be taken as 25 centimeter, and the initial compression we can assume that is 0. Whenever we take the compression, it should be in meters when we apply the formula of work done by the spring. So yeah, do it and get the answer. Next concept, I think we have overdosed all the question. So these are all possible questions. No other than this can come in your JEE mains. JEE advanced is a different type of thing which you can never expect what type of questions will come. Next thing is vertical circular motion. So from this we will be seeing in next lecture. So yeah, I hope you have understood all these things we have learned earlier. So yeah, revise these things, and yeah, next lecture I will be teaching vertical circular motion and the equilibriums, those all things. Fine, that's it for this video. Thank you for watching, and please subscribe, because I'm wasting my entire time just to make you clear JEE Advanced and JEE Mains. As you can see, my voice at the start and my voice at the beginning and the last is very different, because literally my water thing drained in my throat. Yeah, it's not a reason for you to subscribe, but subscribe to support for more videos. That's what I would say. Thank you.